Well, welcome back. This is part two, trying to keep the video short enough that you can digest it. So once again, a little short and sweet trigonometry or vectors table. Now, last time we did the 3, 4, 5 triangle. Now, what happens if we were to change this triangle a little bit and say, let's make r equals 13 and y equals 12? X then equals what? Well, based on the little toolkit we have, we know that r squared equals x squared plus y squared. Therefore, we can say x squared equals r squared minus y squared. 13 squared minus 12 squared. That's what? 13 squared is what? Like 169 minus 144 equals 25, which is equal to x squared. X equals 5. So in theory, this is equal to 5. Let's verify it. Because the nice thing about the component system is, so we said earlier that x is equal to r cosine theta. Well, x is then equal to 13 times the cosine of some angle. We said the angle is equal to the arctangent of y over x. Well, if we come along and say, calculator second tangent of 12 divided by 5, we get 67.38 degrees. So we could say this is 67.38 degrees. The cosine of that is 0.3846 times 13 for the r cosine theta, because that's our r. This part here is this mess. We multiply it by 13, and we get 5. So, and that matches our answer here. So 5 equals 5. Let's verify it at the other end here for the y. Y equals r sine theta. The sine of 67.38 is, I believe, 920. Yeah, 923 times 12. If we multiply that by 12, we get the nice number. It says 11. That's not right. Oh, this number is supposed to be 13. So 13 times 0.923 equals 12, within round off. Get 11.99. So y equals 12, which makes sense. And of course, we can try r squared equals 5 squared plus 12 squared equals 169. Excuse me. Hopefully that hasn't jumped too much. And what we then end up with is r squared is 5 squared plus 12 squared equals 169. Square root of 169 equals 13. So once again, we've gotten back and forth to what we're supposed to get to. And this allows us to be able to prove that our original toolkit, which I have here, does in fact actually work. One last thing for you is you can move the letters around. So we have x equals r cosine theta, right? That means I can divide both sides by cosine theta, and that tells me r equals x divided by the cosine of theta, because the cosine of theta is just a decimal number between 0 and 1, because on the unit circle that the Greeks figured this all out on, it is always going to be that, and the sine is also 0 to 1. So there. So when we have y equals r sine theta, r is equal to y divided by sine of theta. And of course, if you wanted to figure out what the cosine was, I could take this part here and go cosine theta equals x divided by r. Sine theta equals y divided by r. And of course we already did the tangent and cotangents, or not tangent, cotangent, but we did the tangent minus 1 y over x equals theta. Once again, you could multiply and move these things around to solve. So the nice thing about the trigonometry is it also obeys the rules of algebra, and you can move the letters around. Hopefully it clears up, and then we have one last vectors thing for recording 3.